So let me try to spend a little bit of time in terms of how we are trying to address this within E-SystemDesign. So this is a tool that we are developing, a technology that we are developing that we call as Sphinx3D. That is the next generation Sphinx. And let me try to explain that to you at a very, very high level using this slide. Whenever you try to extract the parasitics of any given structure, there are two things you tend to do. Number one, you try to mesh the structure. The number of mesh elements dictates the number of unknowns that you have in the structure, and that is captured as the x-axis over here. The y-axis is the amount of time it takes for you to generate that matrix and the time it takes for you to invert that matrix, right? So that you can capture the frequency response of these TSV structures. If you look at a lot of the commercial tools, because of the way the structures are meshed, especially with TSVs, the number of unknowns tends to be very, very large, and therefore they rely on a lot of these acceleration methods to be able to invert that matrix quickly. And because of that, you will find that a lot of these commercial tools will either run out of memory or consume a huge amount of CPU time, even for a small number of TSVs. So the way E-System is trying to attack this problem is by reducing the number of unknowns, and we do that by a very, very unique technique using a meshless solution. And by doing this, since the number of unknowns are reduced, we can now use acceleration methods to invert that matrix such that the simulation time can be reduced quite a bit as well. So therefore, if you look at Sphinx3D, we believe that the capability we would have in the near future is going to far exceed what any other commercial tool is going to be able to do in terms of the memory required as well as the CPU time required to be able to address the parasitic behavior of large arrays of TSVs. Okay? So therefore, we believe that we can get up to 100x speed up as compared to commercial tools, as well as achieve very high levels of accuracy over a very broad frequency range.